Today we're going to review two concepts and how they play out in equations. The first is opposites. Sorry for the sloppy writing. Opposites are merely, if I say to this you, what number is that? Well, of course that's 5. If I then put a negative sign in front of it, that makes it -5, of course, but it also makes it the opposite of 5. Simply stated, a negative sign tells us to take the opposite of what we have. Another way of thinking of it is that it's like if you put a negative sign here and the 5 here, it's like multiplying it by -1. If I'm going to take the opposite of something, it's really the same as multiplying it by -5. So that's all pretty clear and pretty simple. But it does help us if I say, for example, a problem like this. If I read the opposite of -2, it's much easier than trying to just figure it out mathematically. The opposite of -2 is clearly +2. You could look, and since we're talking about multiplication, an even number of negatives makes a positive. So any way you look at it, the opposite of -2 is 2. Now, if I look at something like this, I'm taking the opposite of the sum of -8 plus 10. So the first thing I have to do is figure out what -8 plus 10 is. Unlike signs subtract, use the sign of the greater absolute value. And so I have 2, and the opposite of 2 is -2. Honestly, I think that's about all you really need to know about opposites. I don't think it gets much more complicated than that. We're going to move on to the next review topic, and that is absolute value. And absolute value technically is the number's distance from 0. And I'll show you what that means using a number line. Oops. Distance from 0 using a number line. So here's my number line, and here I got 0. And if I want to take the number -3, I go 1, 2, 3. This number is -3. So the opposite, the absolute value of -3 is 3 units, or 3. By the same token, if I want to know the absolute value, and these straight lines here are the symbol for absolute value, 2, 3, I've got 3 out. Look, that's also +3. Since distance can never really be negative, you can learn from that absolute value is always positive. A very important thing to keep in mind. So clearly, if I say, I read this, the absolute value of -10 is 10. The absolute value of -7 plus 9, I'm going to make this line longer so you understand that we're talking absolute value. Unlike some kids look at this and say, oh, it's positive, so it must mean +7 plus 9. But since this entire thing is inside the absolute value symbols, just like a grouping symbol, we have to do what's inside of it first. That means we first figure out what is -7 plus 9. Well, it is +2, and the absolute value of +2 is 2. Unlike if I have the absolute value of -7 plus the absolute value of 9. Now, those are two separate problems. The absolute value of -7 is +7, plus the absolute value of 9, which is +9. That gives me +16. The way those can work together is if I have a problem, for example, like here. Let's make up, I don't know, -5 plus 2. I would read this the opposite, because the negative sign is on the opposite outside, the opposite of the absolute value of negative 5 plus 2. So, just like always, I'm going to do what's in the grouping symbols first. The absolute value of negative 5 plus 2 is negative 3. I will bring down my negative sign because I know that I'm taking the opposite of that. So, I'm saying the opposite of the absolute value of negative 3. Well, the first thing I need to figure out is what is the absolute value of negative 3. We know that it has to be a positive number, so that's 3. But this negative sign comes down and says it's the opposite of that. Now, don't be confused. It's not that the absolute value of negative 3 is negative 3. It's the opposite of the absolute value of negative 3. So we first think of just the absolute value of negative 3 as positive 3, and then we take the opposite of that. The way that sometimes this might end up in algebra is if I say evaluate, I don't know, negative x plus 12 for x equals negative 3. If I read this term as the opposite of x, and x is negative 3, I can do one of two things. I can show replacement by bringing my negative sign down and having that, and then plugging in negative 3 for x plus 12, and then I'd say the opposite of negative 3 is 3 plus 12, or 15. On the other hand, it's perfectly fine with me if you just read this term and say the opposite of x, and you look and you say x is negative 3, therefore the opposite of x is positive 3 plus 12. The thing that sometimes confuses kids is the idea that negative x here can be a positive number, which it is. And that's because you don't know whether x is positive or negative to begin with. If x is negative to begin with, as it is in this situation, then its opposite, or negative, is a positive number. Sometimes that can be confusing to people. Let's play out in equations. In the simplest situation, you might have an equation like 4 minus x is, 5. So, if 4 minus x is 5, here's my variable. I want to get it alone. The way I get rid of the 4 is to subtract 4 from both sides of the equation. I bring my equal sign straight down. Notice, the sign in front of the number is the sign of the number. We have minus x, negative x, or the opposite of x is 1, left on one side of the equation, making x equal to negative 1. The next example is one that we have reviewed a little bit, and it doesn't really involve positive and negative numbers, but it does involve getting rid of the parentheses in a specific situation. So if I say 5 plus x plus 1, the quantity x plus 1, is equal to, negative 12. I need to be able to deal with these parentheses. I have to get rid of them. There's no number outside of the parentheses to distribute over them, so I can think of it as a 1, because if I multiply a number by 1, I don't change its value. So 5 plus, I distribute the 1 over here, I have x. I distribute the 1 over the 1, I have 1, equals negative 12. Notice, x plus 1, it doesn't change. If my sign here is positive, this is the same with or without parentheses. I combine my like terms to give me x plus 6 is negative 12. Subtract 6 from both sides, and I have x equals negative 18. Let's look at this same problem if it were 5 minus the quantity x plus 1 equals negative 12. Okay, similarly, I can put a 1 there because it doesn't change the value of the expression. But now, when I distribute, because this 1 is actually -1, -1 times x is -x. -1 times 1 is -1. In other words, when I take the opposite of this entire quantity here, I'm changing both the signs. Most kids I know find it easiest just to think of it as distributing -1 over all of the terms. So 5 minus 1 is 4, and 4 minus x, or you could call it -x plus 4, is -12. When I subtract 4, I'm going to run out of room. The opposite of x is -16. Notice I have same signs. Like signs, add, use the sign of the greater. That makes x equal to +16. The final way that these things play out is with equations involving absolute value. I want to review the idea that a solution to an equation, you know you have a solution when, if you plug it in, it makes it true. So, let's look at this. The absolute value of x is equal to 6. Well, I want to ask myself, what could I plug in for x that would make this true? Clearly, I know that the absolute value of 6 is equal to 6. But there's also another answer, because the absolute value of -6 is also 6. So, if the absolute value of x equals 6, I actually have two solutions, because there are two things that I can plug in to make the equation true. X is equal to -6 or +6. Now, the thing that often confuses kids is, wait a second, we're talking absolute value. I thought that absolute value was always positive. Well, the absolute value part is positive. The part that can start out positive or negative is inside the absolute value symbols. I can take the absolute value of a negative number. I just can't have the absolute value be a negative number. This is the one that has to always be positive. Which brings us to the final thing. What if you see an equation that says the absolute value of x is -3? Some kids will just jump to it after they've done a bunch of this and say 3 and -3. But the truth is, since absolute value is always positive, there's nothing I can plug in for x that will give me a negative number for absolute value. That means there is no solution. And that's all for absolute value and opposites.